So yeah, this is just to say that these are the same thing. But doing it like this is wrong. Doing it like this is right. Right, now let's check out some rules of logical equivalencies. Rules of logical equivalencies. So, to reiterate, a equivalence can be regarded as simply this symbol put between two variables, A and B. It can also be written like this from translation from other mathematical areas, and it means the same. So this is equivalence. Okay, it can be written in both forms. Although there's a huge preference for this one just to maintain cohesion. Okay, so let's start with the commutativity rule. So the commutativity rule specifies that we can swap the terms in expression that contains conjunction or disjunction. So for example, if we have the variable slash formula phi conjunction psi, and make this equal, or make this, it's easier to write it in this notation, to be honest, even though it's that's why people do it, I guess. So you can do it like this as well, right? So like that. So write them in reverse order, I guess. You can change the order is basically what I mean. Or you can do disjunction and this will be the same. It's not the same formula, but it is the same result. Okay, so let's keep that in mind, that these are equivalent in result form. So so the output will be the same. So psi conjunction with phi. Alright, let's move on to the next one. Next up, we have the distributivity or distribution property. So distributivity. By the way, these construct words are like, if you're into etymology, you can figure this one out. But it's basically combining the words distribution with property. And if you get the last one and the starting portions, you get distribute, and you skip the last ones, and you get from property or distributive. Well, there's an if in the middle. VT, right? So it's a combination of both. So that's why that's why it's termed like this in the English language. So to explain, now this property is fairly straightforward. It simply means that you can redistribute your variables, or you can rewrite your expressions better in a different format, let's say. So they remain the same. Not obviously they don't remain the same in terms of the expression itself, but the value, the total value holds. Let me apply the same rule as I did before. So we're actually looking at the value here, the final value, but I'm just for brevity, or just to not clutter so much the space that I have here, which is quite limited. I'll just say that this is v. Okay, so, and we can say that this is equivalent to a distribution of these variables like such. We can grab this portion and this portion and combine them like this. So, and the first order is to combine these two. Then we place the middle conjunction operator, logical operator, and then we then we put the second, or we construct the second expression equivalent, which is this one, disjunction with the Greek letter, the new variable that we're using. This I'm not exactly sure what its name is, but I'll find out in a bit and I'll correct myself. So these have, like, the value holds. They're the same. We can rewrite it like this. Okay, this is not the correct symbol. It should be this one. But here's the thing. Don't the best teachers practice what they teach. I'm not a very good teacher, so that's the reason why. For me, writing this, as you can see, in a piece of plastic, which is a small, very cheap instrument that I use to write, it's very writing these lines is terribly difficult to keep aligned and correct. So for now, it's just, I don't approve of this, but I'm gonna use it. But always keep in mind that this means equivalence. It's just imported from maths. And of course this is different, okay, from logical format, okay, which is the one which we are employing. So logical notation and computation. So it's different, but it facilitates my use now. So distributivity is simply rewriting what we have on one side, rewriting it for any reason as this. And we do this, like, we make these conversions for a myriad of reasons, particularly for if you know a specific formula for implementing a simplification, then it's wise to try out in your head different formats in which you can write your expression in such a way that the things can cancel out, right? We'll see examples in the future. Okay, so that's distributivity. I can give one more example. It's basically the same thing, just written in another, well, it's the exact opposite. So let's say that this is a conjunction, same variables in the same place, just the operators change. Forgive me. Okay, so go like this, then this will be exactly the same as the pardon, did it goof here? So yeah, like this. These are value equivalent, so keep this in mind.